Piglet scours are one of the most common challenges faced by swine producers today and can impact piglets at any life stage. Scours can range in severity and can have a variety of different causes, including stress, nutritional, bacterial, viral, and parasitic. In fact, data from the National Animal Health Monitoring Survey tells us that 57% of all illnesses reported for piglets born and weaned are attributed to scours. There are a number of different pathogens that can impact piglets in early life stages, with Clostridia and TGE ranking highest among young piglets. This slide is meant to illustrate some of the common challenges producers face. Not all of the challenges listed on this chart are scour related. However, once an animal is compromised, other opportunistic pathogens can take hold, which result in a loss of productivity and cost money. The objective is to prevent scours and associated illnesses. Weaning is one of the most challenging life stages a piglet encounters. They're abruptly taken off their milk source, change food sources, possibly move to a pen with other piglets, and can be in a different physical environment. They may face social hierarchy changes where they must adapt to piglets from other litters, compete for food, and are exposed to different antigens that can cause disease. These stressors make a piglet more susceptible for opportunistic pathogens to take hold, and scouring is common at this life stage. Gut health is particularly important to help mitigate the impact these stressors have on the piglet. Research has demonstrated that a low dose of MSPRS-resistant starch can improve performance, resulting in a healthier pig. The impact of piglet scours for swine producers can be very costly, reducing growth rates, increasing treatment costs, and increasing both morbidity and mortality. When dealing with piglet scours, it's important to consider protocols that offer benefits to both prevent and treat scours. Development and maintenance of a healthy gut is critical to the overall health of a piglet. Resistant starch supports the development of a healthy microbiome on day one and can help to maintain that microbial ecosystem. A strong microbial ecosystem can help to prevent enteric pathogens from taking hold. If an animal does scour, resistant starch can help to provide support to the piglet's microbiome by feeding the commensal bacteria, which improves the gut health of the piglet. Introducing MSPRS-resistant starch. MSPRS is a natural source of unmodified resistant starch sourced from potatoes. Resistant starch is a fraction of starch that escapes digestion in the upper intestinal tract, passing to the hindgut where it is fermented by the commensal bacteria that reside there. It's different from other starch sources as it was manufactured to ensure a high concentration and a high quality of resistant starch, which is the portion that is utilized by the healthy bacteria. A low dose of MSPRS can have an impact on the fecal score of the piglet, as observed in research done at the University of Manitoba by Dr. Nyachoti. Scouring is an indicator of disease or potential disease, and fecal scoring is a tool utilized by producers and veterinarians that helps to diagnose sick piglets. A higher score indicates a challenge. Dr. Nyachoti's study revealed that a low inclusion rate of 1% MSPRS showed a significant improvement on fecal score during the first 14 days post-weaning. He suggested that the improvement was a result of an improved microbiome. Some of the established indicators of a healthy microbiome is the production of volatile fatty acids, or VFAs for short. Also, a lower pH. The piglets that consumed a low dose of MSPRS were found to have a higher VFA concentration, as well as a concomitant lowering of the pH in the cecum. Lowering the pH in the cecum has been reported to delay the multiplication of some pathogens, including enterotoxigenic E. coli. Dr. Nyachoti concluded that a low dose of MSPRS had a significant impact on the fecal score of these piglets during the first 14 days post-weaning, as well as other associated indicators consistent with gut health. Evidence has shown the mechanisms through which resistant starch works is a cascade of events. Once resistant starch is fed to the piglets and reaches the colon, It's used as a source of fuel and food by the healthy bacteria that reside there. As the population of healthy bacteria increases, they take up available space and reduce the space for pathogens to take hold. The healthy bacteria also helps to increase the production of volatile fatty acids that lowers the pH levels in the gut, helping to create an unfavorable environment for pathogens. In 2017, researchers from Iowa State University USDA Agricultural Research Services conducted a study using MSPRS-resistant starch. The objective was to further examine these mechanisms. The data from the study looks at the impact MSPRS has on piglet gut health and explores different modes of action. This chart illustrates the fecal microbiota genera changes found in the control group and the group fed MSPRS-resistant starch. The inclusion of MSPRS led to a drastic change in the microbiota profile in the gut. What they found was that bacteria that favored resistant starch proliferated, and that many of these beneficial bacteria produce butyrate. The Clostridium genera are the healthy microbes that do produce butyrate, and you see an increase in these microbes with the piglets fed MSPRS, while Campylobacter is considered an opportunistic pathogen and is more prevalent in the diet without resistant starch. This resulted in an increase of butyrate production. Piglets fed MSPRS were found to have a different VFA profile than pigs fed the control diet. The butyric and lactic acids were present in the MSPRS group in higher proportions, likely because of feeding these butyrate-producing bacteria preferentially. Butyrate is considered an important metabolite in its role to fuel the colonocytes found in the hindgut. An increase in lactic acid indicates an enhanced probiotic bacterial activity. An improved VFA profile is consistent with what we see in Dr. Nyachoti's study, with a low inclusion rate of MSPRS-resistant starch. These three genes are support for the mucosal layer, stimulating secretions from the epithelial cells. These secretions, or the mucus layer, creates a trap for pathogens, which can then be inactivated by IgA, which is an immunoglobulin. MSPRS feeds microbes, and it's suggested that butyrate from these microbes stimulate epithelial cells that then release IL-6, which signals the secretions for the mucosal layer in a complex process that is critical for maintaining the mucosal barrier. The results of this study showed MSPRS-resistant starch in piglet diet causes significant changes in the intestinal microbiota. The study showed an improvement in butyrate production and indications of an improved epithelial barrier function. These two studies demonstrate that a low dose of MSPRS-resistant starch has a significant impact on the gut health of a piglet. MSPRS provides the food the microbial ecosystem needs to help prevent enteric pathogens from taking hold. Research demonstrates that post-weaning piglets fed MSPRS have a better fecal score with higher VFA production, which concomitantly decreases the pH in the gut of a piglet. This is supported by examining the mechanisms in the cascade of events after feeding MSPRS. There is an increase in butyrate-producing microbial species, leading to an increase in butyrate production, which decreases the pH. Butyrate is used as fuel for colonocytes, which supports the epithelial barrier and is an indication of an improved mucosal layer, which is another layer of defense to help prevent infection and disease. MSPRS-resistant starch is a powerful tool that can be used to reduce piglet scours at weaning and to improve the microbiome, resulting in healthier piglets. MSPRS can be used as scour prevention by adding 1% resistant starch into the complete feed or by top dressing 1 cup per litter. MSPRS can also be used as an intervention for scours by adding an additional cup per day per litter as needed. Thank you.